Okay, we're going to look at some linear first order differential equations. And so once again, they're going to be of the form dy dx plus p of x y is equal to q of x. And so basically they're first order because they're differential equations because they contain derivatives. They are first order because they only contain first derivatives, and they're linear because that's not squared and that's not squared. Okay, so I want you to start off with two really simple examples. Okay, so this is one where p of x is just equal to -1 and q of x is equal to 0. Okay, and so we're going to rewrite this like that. And now what we have is we have this idea that we say what function is equal to the derivative of that function. And that's a fundamental question in calculus. That's a super important question in calculus. So I'm going to ask it again. I want you to hit pause and I want you to come back when you know the answer. What function is equal to the derivative of that function? Hit pause. That is e to the x. So y equals e to the x. The derivative of e to the x is e to the x. So e is the number that when you do y equals 2.71828 blah 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 to the x, the slope of that line is always equal to the y value of that line. Very important concept in calculus. It's really critical that you understand that the slope of the line y equals e to the x is always equal to the y value of y equals e to the x. So the derivative equals the function. And then actually in general, because there's a plus c in there somewhere, it's actually going to be y equals c e to the x. And then the derivative of that is going to be that. Okay, so just sort of by looking at these, you're going to know that e's are going to be very important. That you're going to get e to the x or e to some function all the time in here, because basically you're looking for things that when I take the derivative of it, I get basically back the same thing. Okay, so let's look at another one. Let's just change it around really slightly. dy dx is plus y is equal to 0. So then I say dy dx is equal to -y. And then we ask, well, what function is going to do that? Should be not all that hard. It's going to be y equals c e to the -x. Because when I take the derivative of that, I get dy dx is equal to -c e to the -x. And then if I plug that plus that equals 0. That plus that equals 0. Okay. Looking a little bit harder, the next place I want to go is I want to say dy dx minus 3x squared y equals 0. Okay, change that around. So now the question is, what function, when I take the derivative of it, is going to give me back that function with a 3x squared out front? Let me just think about that one. some of you guys are going to be able to go, ah, that's y equals e to the x cubed, because that's a chain rule problem. So then I say dy dx is equal to 3x squared times e to the x cubed. And so actually in general, it should be y equals c e to the x cubed. And then that goes dy dx is equal to 3c x squared e to the x cubed. And then that's going to, and then once again, if I do this minus 3 times x squared of this, I should get equal to 0. Now, I've sort of been messing around here. Because my q of x has been equal to 0, these have actually been separable. So this is actually, that's actually separable. And so I could actually get, I could actually write that as dy over y is equal to 3x squared dx. I take the integral of both sides. I get ln y equals x cubed plus c, and I get y equals e to the x cubed plus c, and that's y equals c x cubed. E to the x cubed, sorry. But I just want you to just be thinking about differential equations can be really, really complicated, but I want you to think that you already sort of have an idea of what's going on and what the answer is to these things. Okay, so then I just want to do one where q of x is not equal to 0. So we've got in general, our solution is that y is equal to e to the negative s of x integral of e to the s of x q of x dx. And then s of x is equal to the integral of p of x dx. And you go, oh my god, that's horribly complicated. But it gets complicated if you don't choose the right functions. And there's certainly not all that many functions that work nicely. But I'm going to choose one, and then I'll give you an example problem. Then I'll give you a one to choose that also works pretty well. So I've cooked one up that's going to look pretty nice when we're all done. And you go, oh, how's that going to look nice? Well, just wait. What I'm going to do is I'm going to say that my p of x is equal to 4x cubed. And my s of x is equal to the integral of p of x dx. So that's equal to the integral of 4x cubed dx. So that's equal to x to the 4th. And then what I'm going to do is I'm going to say that y is equal to e to the minus s of x, so minus x to the 4th, times the integral of e to the s of x, which is x to the 4th, times q of x. Oh, well, my q of x is e to the negative x to the 4th. Well, isn't that kind of funny how that works out like that? That I've got e times x, e to the x to the 4th, and e to the negative x to the 4th, and that's just equal to 1. So I've got y equals e to the negative x to the 4th integral of dx. Well, that's going to be equal to x plus c. So y equals e to the negative x to the fourth x plus c. Okay, so then if you really want to, you can show that if I take the derivative of this, well, let's just do it. So that's my y. Well, the y prime of that is going to be, that's a product rule. So here's my product rule. And so I've got, I'm going to put this there. I should probably actually put a C out in front of that as well, but I'm not going to. And then I'm going to put this here. So that goes there, and that goes there. The derivative of that goes here, so that's just 1 in my notation that I'm using right now. The derivative of that goes there, so that's going to be negative 4x cubed e to the negative x to the fourth. And so then going up, I've got dy dx, which is this. So if I do that, so there's my dy dx, and so I'm going to write it a little bit more complicated. So dy dx is e times e to the x to the fourth, parentheses 1 minus, then I've got a 4x to the fourth plus c, that's going to be minus 4 cx to the third. I think I've done that correctly. Plus 4x to the third times my y, which is that. There's my y. So e to the negative x to the fourth x plus c should be equal to e to the negative x to the fourth. Okay, well, everything's got an e to the negative x to the fourth. So I'm going to cancel that out because everything's got it. So now I've got 1 minus 4x to the fourth minus 4cx cubed plus 4x to the fourth plus 4x plus 4cx cubed equals 1. There's still a 1 left over there. That cancels that, that cancels that, and I've got 1 equals 1, which is correct. So that is the solution to this differential equation right there, which I kind of buried. Okay, so there's your lesson on linear first order differential equations.